Welcome back to my channel. I'm David Mazzei with Mazzei Formula, and this is the MF5 Superlite prototype build. All right, guys, so this is the chassis that's underneath the body of the MF5 Superlite. So you can see here that the body bolts down right here to these 6 bolt holes, 5 or 6 bolt holes on each side. And then back here on this frame rail, you unscrew those bolts and the body just comes right off. It's really simple, actually. And so you can see all of this fabrication that's been done along the side of the car on both sides. These are the cooling pipes that are comprised of the oil lines, 16 AN, and the 20 AN cooling lines that feed the water pumps and the oil pump on the engine, the dry sump system. So if we come up here, we can see a lot of the work that Todd Buddy did at F3 Motorsports. You can see that this is the tubular chromoly section that he added to the nose of the car. This is typically something that would just be aluminum paneling, aluminum plates, but we wanted to have a more rigid structure that could be removable from the front of the car, so Todd welded this up out of chromoly and bent this tubing. And this is the radiator with 2 heavy-duty extreme spall fans. These are 12 inches each. You can see the battery that's on this car is really small. It's lithium, and it's actually a 14-volt battery instead of a 12-volt battery, so it has a custom charging system that I'll explain to you in detail later. These are the brake ducts that cool the brakes directly from these NACA ducts that are in the front here. These are the oil coolers that were supplied by Chase Bays. These are 16 AN lines to minimize pressure drop through the circuit here. And then moving around to the interior, Todd installed this Tilton 900 series pedal box, which is under the dash. And that allows us to have adjustable brake bias between the front and rear master cylinder, and also an independent clutch cylinder. We're retaining the mechanical throttle just for the feel of the 1990s. I know in today's world people use drive-by-wire, but I want that snappy response and that feel of the cable underneath my foot. You can see here that also Todd welded in these brackets so that we could get the angle for the seats and also the drop down in the floor pan. And then over here to your left, you can see the dimple dyed floor section, which raises your feet up to maintain like the angle for your legs, since you're sitting at a layback position. So in this section right here, this is where typically the fuel tank goes in these cars. And we actually cut the middle section out of the firewall here and notched the frame and welded it up so that the front of the engine block could recess into the fuel tank. So this is kind of a trick thing that Todd came up with to get this motor in the car. So center of gravity is really important, and especially being that it's a mid-engine car, when we have a 5th rotor and the engine's so long, we don't want that to extend out the back because we have limited area inside the body. And we also don't want that extra weight past the rear axle. So all of this weight is in front, and we bring that 5th rotor forward in the car. And so you can see that the 5th rotor, or it's actually the 1st rotor in this assembly, is directly in line with the firewall. And in front of the firewall is only the front cover. So if we move around here, we can see that this is one of the radiators for the car. This is the intercooler radiator that cools the water running through the intake manifold. This is our fuel cooler. This is a CWA 400 BMW style electric water pump that will feed the water through the intake manifold for that integrated water to air intercooler system. This is the heavy duty 35 gallon per minute thermostat that we're using on the oil system. And this is going to help bring the oil up to temperature and also minimize the extreme pressure that happens on a cold start from a dry sump system. Since we're having to move this fluid all the way up to these coolers and back, it allows us to have a bypass when we start the car and it's cold initially. If we come around to the passenger side of the car, we have another radiator that's pretty much the mirror image of the radiator that's on the driver's side. And if you take a closer look here at this radiator, you'll see it also has its own independent smaller cooler in front of it. This is to cool the transmission or the transaxle and the differential, which is again the Hollinger sequential MXT. And then we have another CWA 400 electronic water pump, which will work in tandem with a mechanical water pump for the engine block itself. Then over here we have the methanol injection pump, which will actually be used as just distilled water in this system. And this is going to power the direct water injection for the peripheral ports. And then right here in front of me is the miraculous fuel tank design that Todd came up with. We call this the doghouse, which is the center section here. And this allows the front cover to kind of reside between the two gas tanks. And then these gas tanks are balanced through these leveling lines or these leveling sections. So we have an electronic pump on one side of the tank that's the primer pump to get the system started. And then we have a mechanical pump, which is right here on the tank itself, which we need to weld a bracket to, but this mechanical pump will be cable driven off the back of the dry sump oil pump. And this will basically provide us unlimited fuel capacity. Having the overhead is always very important. And then this is our closeout panel for the fuel tank, which covers the fuel tank and protects it and protects you in the passenger compartment from fumes and flames and things like that. So this goes on top of the fuel tank itself, which Todd also made with his expertise in sheet metal and welding. So you can see back here, the suspension on the rear of the car is much different from the suspension in the front. The front is the typical double wishbone design like you would see on an RX-7, but up here we have the shock and coilover is moved on top of the frame rail. And we call this a push rod rear suspension. And you can see here that the engine block in the car is mounted with 4 engine mounts. So it's actually 4 RX-7 engine mounts from a 3rd gen, so that we don't have any movement in the car at all. And these are from Full Function Engineering, and they're a very high durometer polyurethane mount. And then over here we have the Hollinger sequential MXT gearbox, which is about to be installed in the car. And then on this shelving behind us, we have the array of fabricated materials that were done by Walker Morgan. And this is also the drive system for the front of the engine that was done by Darren at DLH Manufacturing, which we'll get into more detail on that. There's like an independent drive shaft for the water pump, the oil pump, and the alternator. And these are our tanks, the dry sump tank over here, and the water methanol injection tank, and the coolant overflow tank. All right, guys, so now I want to talk about one of my favorite sponsors. This is Spec. Spec is located in Birmingham, Alabama, which is where I'm located. I want to thank Spec Clutch for the triple plate clutch that we got on this new trans. You guys check out Spec. They've got a great new clutch package for the RX-7. It's called the Mini Twin and the Mini Triple. Super small clutch pack, really lightweight, handles a lot of power, and they've got a hydraulic throwout bearing that's super linear. And today I'm going to be installing one of their triple plate units for my 5-rotor engine. And this triple plate is special. It's different from all the others because it has an aluminum flywheel. And so I'm going to take this thing apart and I'm going to show you how it works inside. And basically having this aluminum flywheel with a chromoly wear surface is going to make the car rev a lot faster, and it's going to take a lot of the load off of the dog rings so that the sequential transmission will last longer and it will behave better and shift faster. So I'm going to take this thing apart and we're going to install it on the motor itself. And I'm going to walk you through the process. This is our pressure plate assembly right here, which has 3 plates inside of it. I'm I'm going to take the pressure plate assembly off. You can see the flywheel. So this flywheel is made out of billet aluminum. I'm not sure exactly the material. I don't know if it's 6061 or 7075, but it's pretty solid piece, and it has a steel ring gear. So this keeps the flywheel, like if something goes wrong, it keeps it from exploding because it has a steel ring gear. And then also the starter won't eat it up. This is what your starter grabs to turn the flywheel itself. And then we have this wear surface here, which I believe is chromoly, and this is replaceable. So you can take this wear surface off and you can replace it in the future. And that's because you don't want the friction material digging into aluminum itself. So this wear surface is basically bolted on here, as you can see. And this is what the clutch discs, grab onto to give you the power transfer. So then you have this washer plate that goes on top of the flywheel, and this is going to distribute the load when you apply the torque to the bolts that hold the flywheel to the engine itself. And this is our pressure plate assembly here. If you want to take a closer look at this while I take it apart, you can see that this is basically the billet cover that has the fingers that press on the discs. And this has all been balanced. So this is our balance line that rides in line over here with the flywheel itself. And that's to make sure it all stays together at high RPMs and there's no vibrations. And then as you take this apart, there's these plates that sandwich each one of these discs. And as you can see, each one of these discs has a spline section inside. And so we have to line all these splines up, and we're going to use an actual input shaft to do it. Generally, you have a plastic tool, but I'm going to use an actual input shaft to line the splines up because the tolerance is a lot tighter than the tool itself, and that's going to make it easier to stab the transmission, and it's going to decrease the likelihood of bending something or warping a plate or having a hard time or messing up the pilot bearing itself, which rides on the end of this input shaft. So the first thing is I always make sure I have everything laid out, all of my tools, all of my hardware, and everything that I'm going to use for the project, and I keep it all very clean, and I go in very particular order. I think the OCD of being clean and having everything ordered and laid out is important so you don't forget things, you don't make mistakes, because when it comes to something crucial like this, your life depends on it. If one of these bolts comes loose, you don't do something right, it can fly out of the transmission and hurt somebody. So let's go ahead and start installing this clutch and flywheel. So the first thing I'm going to do is I'm going to use ARP bolts. These are from a 4AGE engine, which is a Toyota motor, but they fit great for the Mazda RX-7. And this has an RX-7, obviously rear counterweight, and this is an RX-7 flywheel. So I'm going to use ARP bolts because they're 12.9, which means that they're the highest grade that you can get basically in steel that allows me to torque them to the highest specification. So I'm going to torque them to around 70 foot-pounds, which is a little bit higher than what most people torque them to. So I'm going to take my friction plate or my washer plate. I'm going to line the flywheel up with the holes. The flywheel sits on the back of the counterweight with this recess here that lines it up. And then these bolts have a little bit of a lip in them inside, which helps center the bolt itself. I'll just thread these in by hand very carefully because we don't want to mess up our expensive crankshaft counterweight. It's important to use brake parts cleaner if you want to get any kind of residue, grease that's on the friction surfaces off before you break the clutch in. All right, guys, thanks for watching my video. I'm David Mazzei with Mazzei Formula. This is the MF5 Superlite project. Stay tuned, I got some more fun stuff coming up when we stop this transmission.